Hey guys, this is Coach Brian bringing you your 8.2 notes for Law of Cosines. Today's warm-up is just a review of 8.1, so I'm going to jump over it so that I can get straight to today's content. Law of cosines is used to find missing sides and angles of oblique triangles. Remember, oblique means non-right, so no 90-degree angles. There are two situations where you can use the law of cosines. The first one is if the triangle presented to you is given with side, angle, side information. The second is if you are given side, side, side. So either side, angle, side. Remember, that's what we call an included angle, or all three sides. There are three kind of general formulas that we can use, or equations that we can use for the law of cosines. The important thing to look at here is that there are some patterns to it. One, if you are looking for a missing side A, your other two letters, B and C, will make up the rest of your equation. So if you're looking for a squared, it's going to be b squared plus c squared minus 2bc times the cosine of the capital that matches your first letter. So you'll be given these when you take your exam, but ultimately they follow this same pattern every time. If I'm looking for b, then my equation is going to use AC, and then at the very end, I'll have a capital B. If I'm looking for C, my equation is going to be made up, my equation will be made up with AB, and then at the end, I'll have a capital C. So they follow that same pattern throughout. The notes ask, what happens in the first equation if angle A is a right angle? If angle A is a right angle, is this formula useful for right triangles? If we look really quickly, if angle A was a right angle, that means it would be 90 degrees. The cosine of 90, if you remember from your unit circle, the cosine of 90 over here at 0, 1, cosine equals x. So in this case, the cosine of 90 equals nothing, equals 0. So if this whole thing equaled 0, and then this is being multiplied by 0, pretty much all of this stuff would be canceled out, and you would just be left with a version of the Pythagorean theorem. So to answer the question, is this useful for right triangles? The answer is no. Just use the Pythagorean theorem. Now let's get into some examples. For this first one, and all of them, it says round side lengths to the nearest thousandth. So anytime you're solving for a missing side, you're going to round to the nearest thousandth. And for angles, any angle, you're going to round to the nearest whole number, or nearest whole degree. If there are units, use the units. So for this first example, it says find little a. Little a is a side, and it's across from angle A. If you look, we have side C across from C. We have side B across from B, and we have angle A. Angle A. That means this given information is a side, angle, side. Side, angle, side. Since it's side, angle, side, we can use the law of cosines. And we would use the formula or the equation that's set up for finding A. Now remember, when you're looking for a, b and c are going to make your equation. So it's a squared equals b squared plus c squared minus 2bc times the cosine of the capital letter that I'm looking for, or that corresponds to the side I'm looking for. So now I'm just going to start plugging in some values. I don't know a. Side B is 5. Side C is 7. BC is 5 times 7. And then I'm using the cosine of 39. Cosine of 39. Now, you could do this a number of ways. You could go ahead and start simplifying, but one thing I want to point out is this left side is squared, which means at some point during this problem, I'm going to need to get rid of that. And to do that, you find the square root. To get rid of a power of 2, you use a root of 2. And I'm going to have to do that to both sides. So I might as well just go ahead and do it now. Now, you could take this entire thing and go ahead and type it into your calculator. You need to make sure it's in degree mode, and you need to make sure you type it in exactly like this. So everything needs to be under the radical. These parentheses need to be here. You want your calculator to do everything in the correct order of operations. And when you do this, you get a solution of 4.427. This is a side length, so we're going to leave it to the nearest thousandth, which is 3 decimal places. For question number 2, it says in triangle ABC, B is 4 inches, C is 5 inches, and angle A is 51. Find the length of angle A. So really, this is the exact same type of problem. I've got angle or triangle A, B, C. Order of those doesn't matter. You just have to be sure that across from it you put the little letter that corresponds. And so my given information for this one is that B is 4 inches, C is 5 inches, and angle A is 51. And I'm looking for side A. So for this one, I'm going to also use the law of cosines when it's set up to solve for A. Now, I'm going to plug in what I know. I do not know A, but I know that B is 4, C is 5. And I know that A is 51 degrees. Now, again, at this point, you've got an exponent that you need to cancel. So you're going to find the square root of both sides. And now, at this stage, you can type this entire side into your calculator. Make sure it's in degree mode. And when you type this entire thing in, you should get that A, which is a side, equals 3.978 inches. And they give us the unit, so make sure that you include the unit of inches. For question number 3. It says in example XYZ, here's X, here's Y, here's Z. Find a measure of angle Z. So in this situation, they give us a triangle, and that triangle is X, Y, Z. And they give us the 3 sides, so make sure you put them in the correct spot. Your triangle doesn't have to be perfect like on mine. There's no way that X is the longest side, but also the shortest. So your picture accuracy isn't hugely important. You just got to make sure that the correct sides are across from the correct angles. So here they give us three sides, and we're looking for angle Z. So what I'm going to do is I'm going to set up an equation that uses Z as what I'm solving for, Z squared, little z. And although our original examples were A, B, and C, I can still just make an equation using the other two letters. So Z squared equals X squared plus Y squared minus 2 times XY times cosine of capital Z. Now, next step is going to be to plug in what I know. When they give you all the sides, you should be able to replace all the lowercase letters since you know them. What you will not be able to fill in is the cosine of the capital letter. I do not know Z. I am looking for this unknown angle. And then one thing I've said to my students is if you know you're looking for an unknown angle, like that's your final thing that you're going to do, then your final step should be inverse trig function. That should be your final step. So if I am looking for an unknown angle, the last thing I'm going to do is I'm going to end up getting rid of this cosine through the inverse cosine function. So let's start simplifying. 9 squared is 81. 3 squared is 9. 7 squared is 49. Minus 2 times 3 times 7 is 42 cosine Z. Now, it's very important here that you remember the order of operations. Okay, a lot of people are tempted to add these two numbers together, 58, and then subtract 42. But you can't do that because 42 is currently multiplied by the cosine of Z. So these guys right here, these are bonded together, okay? You cannot do anything with them right now. You have to isolate Z, because it's what we want to know. You want to isolate Z by moving everything to the other side. So we want to start from the outside in. And I've got this positive 58 just hanging out by itself. So I'm going to subtract 58 from both sides. That leaves me with 23. And now I've still got this like bonded unit over here, and I want to get rid of the 42. Right now it's being multiplied, so I'm going to divide both sides by negative 42. So right now I've got 23 over negative 42 equals cosine Z. And I want to get rid of the cosine. This is my final step. So remember, my final step should be the inverse trig function. I got to do it to both sides. On the right side, these will cancel each other out. So that leaves me just with Z, which is what I'm solving for. So what I need to do is I need to take this entire left side and type it into my calculator. Now when I do that, I get that Z equals 123.204. This is an angle, and the instructions said round your angle to the nearest whole number. So I'm going to say that angle Z equals 123 degrees. Example 4 is just like this one, so I'll actually work it a little quicker. Here's our triangle. It is triangle X, Y, Z. Again, the letters don't matter. Doesn't matter where you put them. You just got to make sure that across from a capital X is a little x. Across from capital Y is a little y. Across from capital Z is little z. That's all you got to do, is make sure everything corresponds. Now, we're going to plug in what they give us. They tell us that x equals 3, y equals 10, and z equals 11. And these are all feet, all measured in feet, so I'm going to just go put a little dash behind those. And I'm looking for angle z. Angle z is the one I don't know. So just like last time, I'm going to set up an equation using z. And if it's set up for z, that means y and x will be all the other like plug-in letters in this equation, except for at the very end, the capital Z.
At the cafeteria dock.
Sorry, I'm not going to re-record this.
District people in the building, truck 1701 and 2101, please move your vehicles immediately. Thanks and go Mustangs.
All right, I'm not re-recording this. All right, Z is 11, X is 3, Y is 10, and then cosine Z is the thing I don't know. So I'm going to get to simplifying. 11 squared is 121, 3 squared is 9, 10 squared is 100, 2 times 3 times 10 is 60, cosine Z. Now remember, these things are bonded together. So I cannot just add, subtract, and do whatever I want with that 60 right now. So what I'm going to do is I'm going to do 100 plus 3. Oh, I made a little mistake right there. 3 squared is 9. So I'm going to do 100 plus 9, which is 109. I've still got my 60 times cosine Z hanging out back here. They're stuck together. Can't do anything with that right now. And now, just like last time, I'm going to subtract first. And you'll notice this is going to usually be your order of operations here. You're going to subtract first. That leaves me with 12. I'm going to divide next by negative 60. And then the final thing I need to do, I need to get rid of this cosine. So I'm going to find the inverse cosine so that that will cancel out. And so what I've got is the inverse cosine of 12 over negative 60 equals z. And I can plug this directly into my calculator. And I get that z is 101.536. Now this is an angle, so I'm going to round it up in this case to 102 degrees. The reason I round it up is because the next number behind the ones spot is 5 or greater. All right, hopefully this helped, and I will see you again for 8.3. Thank you.